Alright folks, once in a while I like to do some fun stuff with my coding. Once in a while I'll tackle one of these riddles and try and solve it with code instead of with like my brain. Basically I'll have the computer solve my problems. So here I'll just be playing the video and you'll see my process for tackling this in code. I have no idea how I'll do it, but we'll see. Good luck to myself.
The villainous Dr. Schrodinger has developed a growth ray and intends to create an army of giant cats to terrorize the city. Your team of secret agents has tracked him to his underground lab. You burst in to find that it's a trap. Dr. Schrodinger has slipped into the next room to activate his device and disabled the control panel on the way out. Fortunately, your teammates are masters of spycraft. Agent Delta has hacked into the control panel and managed to reactivate some of its functionality. Meanwhile, Agent Epsilon has searched through surveillance to find the code for the door, 21014. All you have to do is enter those numbers and you'll be free. But there's a problem. The control panel has only 3 buttons, one which adds 5 to the display number, one which adds 7, and one which takes the square root. You need to make the display output the numbers 2, 10, and 14 in that order. It's okay if it outputs different numbers in between, but there's no way to reset the display. So once you get to 2, you'll have to continue on to 10 and 14 from there. Not only that, Agent Delta explains that there are other traps built into the panel. If it ever shows the same number more than once, a number greater than 60, or a non-whole number, the room will explode. Right now, the display reads 0, and time is running out. There's only one way to solve the puzzle with a few small variations. How will you input the code to escape from Dr. Schrodinger's lair and save the day?
So let's see if I can tackle this one in code. So my plan already, I'm thinking I'll just set up a bunch of functions that just check. Well, I need to check to see that the next number, if it's I'm thinking I'll do like a queue kind of thing. Okay, I'll see what I'll do with this. All right, it's been a while since I've been in JavaScript land, but let's go with this. Okay, so yes, the second I start typing a comment, it's in Python. All right, so first I will want to have like a check if valid, if number valid. Invalid. When solution found. I can't spell the word found apparently. Okay. So actually, I don't need a function here. I'll just call functions here. So keep track of a queue. So here's my queue. Bam. Made a list. The first thing is 0. So I will need to do a while loop while queue. While a queue has length, then I want to pop it off. So I will do queue pop. Wait, is that even a thing? Yeah, it removes the last one. I want to pop from the beginning, so that's called the shift, I think. Oh man, it's been so long. So current state. I don't know. Okay, so the current number equals, and I think I will put that at the end, right? So I need to grab the last one from the history, and I need to grab the history length. All right, -1 there. So from that number, I'm going to look at 3 possibilities. So here's my 3 possibilities. So first is, and I need to check to see that those numbers are valid. Okay, very good. So here we need to then say basically if num is valid, +5. I guess I need to also check the history. So if +5 is valid, then we need to take a copy of the current state. Okay, so I'm just going to put all these things in one place, basically. Okay, so I have the 3 possibilities all together, and I'm just going to loop through them. So let's say for possibility Oh, I need to put my, oh my goodness, what is going on with me? I need to put my declarations, huh? So this is going to be const possibility in possibilities, and then I'll loop, move you up. So this time it's possibility in there, or is it of? Oh, I think it's of. Not if, of. So for const possibility of possibilities, we validate the number, do a deep copy. If it's valid, we can add it. Push that number to the list. We need to verify that the list is good. So if no dupes has dupes. If not, it has duplicates. If the new state history doesn't have duplicates, then we can add that to the queue. Only then does the new state gets added. So push the new state there. Okay, so the last thing I haven't checked is the winning solution. So if there are no duplicates, then I can just check if one. So check if one, else continue working. So I need to do this has duplicates function, and then function, and then I have another one which is, so if is solution. I'm curious now, why am I keeping it as an object? I could just have a list of lists, which I think makes a heck of a lot more sense. So let's just do that, or an array of arrays. So I no longer need history. So anytime it says history, I don't need you. In which case, I don't need a deep copy. I could just make a regular copy. Okay, that's a heck of a lot easier than that. Current state, I think it's called. So that is that. I don't need. Okay, cool. So I don't need this deep copy thing like I thought I was. Has duplicates array and is solution, which is the new state. Then I will break. I guess I could just make it into a function, which is a thing. All right, fine. And just make it return. Okay, so this is going to be a return. That is working, call main, and Lord knows this is not going to work the way I think it does, but let's see it anyway. So I need to check two things. I need to make sure this is valid. Oh, there's another one I need to make. This thing called is solution. These three things are all I got to do. So if the number is valid, it is valid if it is a whole number. So it needs to be whole and has no duplicates. So actually, I can just call this in here. So let me say if it has no duplicates, thing should be part of the number being valid. So has duplicates is called in here somewhere. So no duplicates, which means I don't provide a number. I need to provide the entire. Yeah, I think it's okay because like I don't push it until the end anyway. So I should add the new number to that list, the new state list, and then check. So this thing should be an array as well. So we'll check the entire array. Okay, so push possibility. So here, I'll push the possibility here. So first I will create my state. For each possibility, I will create a new temporary state, push that possibility in, and then check if it's valid. Check if there's any kind of validity there. So I no longer need this dupes thing. I can just check if the solution is there, and that's basically it. I kind of like having a function called no dupes actually. Has duplicates. I kind of like that abstraction here. How do you check if an array has duplicates? Well, I'll just do a history thing and make it an object, and so else return false. Because if you get through this, if you encounter something that you've never seen before, or if you encounter something you have seen before, you should then you have duplicates. Otherwise, return true. Okay. That's the last number. So I'm going to say last num is, if I do math.floor, it should equal to that last num. And the last num should be not greater than 60. And oh, it's double and actually. I have to like relearn all of JavaScript just from scratch. Okay, and the has no dupe, has dupes, and does not have dupes. And you just pop the array in there. Oops. Okay, so we return the whole thing. I think that's valid. I think this is valid. Is solution means that you have to go through each one and check. So this, and I don't need the possibility. I need to get the new state, which is the list. That's what I need to feed in. Okay. All right. So now is solution. So the is solution is it has numbers 2, 10, and 14 in order, regardless of what's in the middle of that. Sure. That's the only time. So that means you've run out of solutions, so you're done. Otherwise, return false. I think that should work. Okay. So for code that I have yet to run, I should have tested this, by the way. But anyway, not testing, just running. Army. And it seems like it's stuck, going on forever. Okay, so I did something wrong. Why did it count that as valid? Because that's a duplicate, right? Oh no, I suppose no, this is true. You need to return true there. Okay. So if you've never seen it, then it has duplicates, hence the name of it. So false, otherwise, which is the thing you want. Okay. So let's try that again. Okay, it's still going on forever, it looks like. Okay, I think I'm going to have another thing for num is valid, which is maybe state is valid is more proper. So let me modify this reference. Can I change symbol, rename symbol? I'm going to say state is valid. Okay, and the thing is, the new state is in there, and I'm going to see like solution state. What am I trying to do here? I'm trying to say basically, once you find a 2, you should only look at solutions that have the 2 in it. And once you find a 10, that's the thing. So you're going one at a time. You don't look at all possibilities forever. You need to restrict yourself, basically. So what I'm trying to say here is, once I look at my state is valid, I check my new state, and I have some kind of solutions that are already known. So y and x is okay. Anyway. Been a long time since I've done JavaScript. Okay, so if 2 found, 10 found, and these possibilities, which possibility? So here is basically like if possibility. Oh no, if possibility is equal to 2 or 10, not 4. Okay, and so what do you do with these things? Basically, if 2 is found, anything, if it doesn't have 2 or 10, then you throw it out. State variables, 2 found, 10 found. So if 2 found and 10 found. Oh wait, it needs to be in order, right? Crap, the order matters. So for this part, I need to say if possibility is equals if that and that. If 2 hasn't been found and the possibility is 2, we say 2 found is true. If 2 found and 10 not found and 10 found and possibility, oh god, okay, possibility is equal to 10, then 10 found. So the order there matters. Oh man, okay. So, going back up here. 10 found. If index of 2 is less than 0, turn false. If array index of 10 is less than 0, turn false. False return true. Okay. It went through all possibilities and couldn't find anything? How's that even possible? The hell? Here we have a 2. That's good. I was pushing it to the end. That's why? Oh, because I'm popping it. I should be shifting it. Okay. That's okay. I changed up something. That's all. Okay. Holy crap, we came to a solution. Took a while, but okay. Very good then. Oh my goodness. Solution found there. Alright. It prints everything on one line. So let me maybe make that a little bit neater. And for my print statement here. Alright, coolios. Alright, so it looks like we got ourselves a solution finally. Took a while, and what I found out is I was kind of doing things inefficiently. Basically, I was pushing and shifting in the wrong place. But effectively, we did get our solution here, and it goes like this, folks. Okay, so I'm anxious to see what they have as a solution. So let's see if we are correct.
3, 2, 1. You look over your options. Adding 5 or 7 increases the number, and the square root button will make it smaller. But there are only a few options where you can use that button: 4, 9, 16, 25, 36, and 49. You'd love to make 4 or 16, then you could hit the square root button once or twice to get 2. But you can't make either with just the 5 and 7 buttons. What will you do? You look at the other possible options for numbers you could take the square root of. 9 you can't reach. 25 and 49 would take you back to 5 or 7, and you can already get to each of those. 36 is your only option. You add 5, 7, 5, 7, 5, 7, and then hit the square root button. Why that series of 5s and 7s? It's somewhat arbitrary, but you know that you want to avoid 10, 14, and perfect squares, since you'll need them later. This gets you to 6. Does that help? Looking at your options, you see that 16 is now in your sights. You add 5 twice more to reach it, then hit square root twice. That gets you to 2. You're on your way. Now to 10. You can't get straight there through addition alone, so you're going to have to reach another square. Taking the square root of 9 or 25 would get you to a good place, but it turns out that 25 is unreachable from 2. So you add 7 to get to 9. Then take the square root again. That gets you to 3. Adding 7 again makes 10. Finally, you need to reach 14. Thinking backwards, you imagine where you could be before 14, 7 or 9. But 9 won't work because you've already used 9. However, you could get to 7 by reaching 49 first. You add your way towards it, being careful not to hit any of the numbers you've hit so far. You thread your way carefully, adding 5 5s and 2 7s. Then square root to 7 and add 7 more. The door opens and you're out of the trap. Thanks to your problem-solving skills, your team gets Schrodinger's cats out of the box in the nick of time. As for Schrödinger, you can be certain of one thing. He'll be spending quite some time in a box of his own.
All right, that was very interesting, and took me a while to get there, but I definitely like the idea of having the computer automate that. Did we get that? Yeah, we got to 30, we got to 36, 6, got to 2, 9, 3, 10, and then all the way up to 7 to get to 14. So it did work. Hey, we got there, and I think there are probably other ways of doing it. Probably, I just didn't bother. Anyway, folks, that was fun. I hope that was helpful. I definitely had an enjoying time, like getting through the solution with all this. Look at this hot mess of stuff. That's my solution. I could have used logic, but instead of that, I just coded it. So if you like this kind of content, make sure to like, subscribe, all the good things, and I will see you all later.